We will now find the resultant gravitational field strength at a point under the influence of more than one objects. So let's consider a point P and near to the surface of the Earth. We can find what is the value of G that is due to the Earth alone. But this point G may also be near to another object, say the Moon. We can calculate the value of Gm due to the Moon alone. The question is, what is the resultant gravitational field strength at point P then? Since gravitational field strength is a vector, we will have to add Ge and Gm vectorially. So it's a vector sum of these two vectors, and hence numerically it is the difference between Gm and Ge. Okay, so let's say that this point P is the distance x from the center of the Earth, right? Note that it has to be from the center of the Earth, not from the surface of the Earth. And if we know that the distance between the Earth and the Moon is 3.8 times 10 to the power of 8 meters, we can actually write down the expression for G at any point of distance x along the centers of the Earth and the Moon. Graphically, this is what we can do, right? So Gm is towards the Moon, right? So in this graph, note that it is drawn with a positive value. Why positive? Because we have taken right side as positive. Since Gm is pointing towards the Moon, it's going to be positive. Another thing to take note is that the value is higher here compared to here, right? So it increases as it goes towards the Moon, and it decreases as it moves, as the point moves away from the Moon. Right, that should make sense because we expect that the gravitational field due to the Moon to be stronger near the Moon. What about the gravitational field strength due to the Earth alone? Okay, so Ge is now towards the left. Remember, we have taken right as positive. So gravitational field strength towards the Earth, it's negative. Okay, it's now negative. And it's going to be a greater negative value near the surface of the Earth and a smaller negative value far from the Earth. If we were to combine these two graphs or add them together vectorially, we will have the red graph, and there will be a point here where the resultant gravitational field strength is 0. And this point should be closer to the Moon as compared to the Earth. And it shouldn't be surprising because the gravitational field strength due to the Earth is stronger if the distance is the same. So it has to be closer to the Moon so that the two gravitational field strength Gm and Ge will totally cancel one another. Let's look at example 4. Right, when you want to find where is the zero gravity point, that's when G is 0, we can solve the equation that was given previously, right, and just solve for x. And then we find that x equals to 3.4 times 10 to the power of 8. Okay, that's really far from the center of the Earth.